Hello friends, welcome to engineering tutorial. So we'll continue our discussion related to error analysis. So here is another question. So here it is given that a unit feedback control system has a forward path transfer function given by gs is equal to k by s into s plus 9. We have to find out the steady state error when this system is subjected to input given as 1.5 plus 2t plus half t square. It has been asked to take the value of k equals to 10. Okay, so this is a different way in which the question has been presented. So here if we substitute this k with 10, this becomes gs is equal to 10 by s into s plus 9. This means this much only. And important things to look out for: unit feedback system, it has a forward path transfer function which is given as this, which means it is the OLTF, open loop transfer function. Okay, this much is clear. Then as far as this input is concerned, so here the input is represented as this 1.5 plus 2t plus half t square. So here it consists of three separate inputs: step, ramp and parabolic. So if we compare them with the respective values of the respective formats, here it is a, at and half at square, the basic formats. Then here the value of a is equal to 1.5, here the value is equal to 2, and here the value is equal to 1. This is a unit parabolic input, this is a ramp input with slope 2, and this is a step input with the constant value equals to 1.5. So this is very important, finding out the value of a for each input. Next is considering each of these inputs separately and finding out the error coefficients applicable. So first, the step input. For that we have to determine the position error coefficient. Okay, position error coefficient Kp. So that is equal to limit s tends to 0 gs, which is equal to limit s tends to 0 10 by s into s plus 9. So very simple, it is 10 by 0 into 0 plus 9, which is equal to 10 by 0, which is equal to infinity. Okay, so Kp is equal to infinity. We know that the steady state error is for a step input is given by a by 1 plus Kp. So it not makes any difference what the value of a is, it will, regardless of what the value, it will always be 0 because the denominator will always be infinity. So here it is 1.5 by 1 plus infinity, which is 1.5 by infinity, it is equal to 0. So the steady state error because of the step is input is equal to 0. Then we have the ramp input. Okay, for the ramp input we have to determine the velocity error coefficient Kv, which is equal to limit s tends to 0 s gs, which is equal to limit s tends to 0 s into 10 by s into s plus 9. SS got cancelled, so when we substitute 0, it is equal to 10 by 0 plus 9, which is equal to 10 by 9. That is equal to 10 by 9. It is 1.11, I think it will come. Yes, 1.11. this is the value of the velocity error coefficient, kV equals to 1.11. Now we know that the steady state error due to ramp input, that is given by A by kV. Here A is equal to 2 for the ramp input 2t. A is equal to 2, so it is equal to 2 by 1.11, which is equal to 2 divided by 1.11, which is equal to 1.801. 1.801. This is the steady state error due to ramp input. Then we have the parabolic input, unit parabolic input. So for that we have to find out the acceleration error coefficient. Parabolic input, we have to determine the acceleration error coefficient, Ka, which is equal to limit s tends to 0 s square gs, which is equal to limit s tends to 0 s square into 10 by s into s plus 9. This gets s in the numerator, that is equal to, when we substitute 0, it is limit s tends to 0 s into 10 by s plus 9. That will be 0 into 10 by 0 plus 9. That will be equal to 0. 0 by 9, which is equal to 0. So Ka is equal to 0. Steady state error due to parabolic input is given by A by Ka. Here Ka is equal to 0 and the value of A for parabolic input is equal to 1. So it is equal to 1 by Ka, which is equal to 1 by 0, which is equal to infinity. So this for parabolic is equal to infinity. So the total error, okay, the total steady state error, that is equal to the steady state error due to step input plus the steady state error due to ramp input plus the steady state error due to parabolic input. For step input, we calculated the error is equal to 0. For ramp, it was equal to 1.8018, okay, 1.801, and for parabolic it is equal to infinity. So the total will be equal to infinity, because infinity added with anything, it becomes infinity. So the total error is equal to infinity. Okay, this. Okay, so this is another question which we dealt with. So slightly different kind of a format. So my objective here is to expose you to different kind of questions which are presented in different ways, so that anytime you face any kind of question, you do not get confused, you know how to deal with it. So I hope you like this video, and please subscribe my channel Engineering Tutorial for more such videos related to engineering, science and technology. Have a great day. Thank you very much.